frustrated about the quality of your glasses? Well, I'm always here for you. In today's video, we will go through the common lens material and their safety, density, cost, and optical quality so that you can make the best decision in picking your glasses. Let's take a look. Hi everyone, welcome to my channel. In the previous video, I went through how to pick the right glasses frame according to your face shape. But really, choosing a pair of comfortable glasses is so much more than that. And the lens type and lens materials are essential. Depending on the number of segments that the lens has, lenses can be single vision, bifocal, trifocal, or progressive. So I bet the vast majority of my audiences are teenagers or young adults, right? People in their early 20s should be roughly have 10 diopter of accommodation, so we usually don't need bifocal, trifocal, or progressive lenses designed initially for elderly with presbyopia. Generally, a single vision lens should be sufficient for younger people. If you are young and have insufficient accommodation, it is recommended to undergo visual accommodation training rather than wearing multifocal lenses. First, lens material. There are actually many options out there, so it can get pretty confusing, especially if you are not in the optical world. So out of all lens materials, there are cheaper and more affordable lens options out there, all the way to premium lenses that have better optical quality, and you can get better out of them. But of course, they are a lot more costly. The most standard glasses lens used nowadays is a plastic called CR39. It is commonly referred to as basic lens or standard lens or the index 1.5 lens. CR39 is a durable, lightweight plastic used initially on military planes in World War II. CR39 plastic is basically allyl diglycol carbonate, invented by an Ohio-based company named Columbia Southern Chemical Company, which is a subsidiary of Pittsburgh Plate Glass Company. CSCC initiated a Columbia Raisins project and initially achieved its goal on its 39th attempt, so we call the new plastic CR39. In 1949, Armalites introduced CR39 lens to the optical world. CR39 makes an excellent lens material because it's nearly 50% lighter than glass because of its lower specific gravity. It is highly transparent, less likely to shatter than glass, and has decent chemical and heat resistance. Not only that, it is straightforward to tint and has a high Ab number. Ab value is a measure of the lens material dispersion of light. A lens with low Ab value causes a high dispersion and unwanted chromatic aberration. Wait, what? What do you mean by chromatic aberrations? So, in short, the refractive index of the lens varies with the wavelengths of light. Light with shorter wavelengths sets refracted more than light with longer wavelengths. Hence, the lens fails to focus all colors on the same focal point and leads to an outline of unwanted paint along the edges of the object. These are chromatic aberrations. Chromatic aberrations are particularly obvious along metallic surfaces of where there's a high contrast between the light and dark object. So for example, dark paint on the white sheet of paper. In the optical world, a higher Ab number means less dispersion. Hence, the CR39 lens has fewer chromatic aberration and higher optical quality. There are downsides to CR39 lenses, however. It is less scratch resistant than glass and fit for rimless glasses. And most importantly, it has a less than ideal refractive index, so the lens can get pretty thick and visually unappealing if you have a higher prescription. CR39 is usually the standard lens for most companies, but there are other more premium and of course more costly options you can choose from. One example would be the polycarbonate lens. Polycarbonate is a special type of plastic developed in the 1970s for aerospace applications. It is used for astronaut helmet visors and for space shuttle windshields. Because the polycarbonate lenses are light and impact resistant, they are slowly adopted for using eyeglass lenses. This is especially important in athletic children or individuals who engage in activities with a high risk of eye injuries. For those people, we don't want their glasses to shatter and have those sharp plastic into their eyes, which will be an ocular emergency. Here in the United States, polycarbonate lenses have become the standard for safety glasses, sports goggles, and children's eyewear. Because they are less likely to fracture than regular plastic lenses, polycarbonate lenses are also a good option for rimless glasses because lenses for these glasses are attached to framed components with drill mountings. Polycarbonate lens also offers nearly 100% protection from UV light. I find it interesting that while PC is very commonly used in the United States, it is used infrequently in China. I'm not exactly sure why that is, but every country has its trend, I guess. The disadvantage of polycarbonate lens is that they are difficult to tint, and although they are impact resistant, their abrasion resistance is highly recommended that you have anti-scratch coatings put on your glasses if you order a PC lens. They also have a lower ab number, which is the lowest among all lens materials, and people wearing polycarbonate lenses may notice these fringes of color along boundaries that separate dark and bright parts of image due to chromatic aberrations when they are looking through the sides. This distortion can be pronounced if you have a higher prescription. Next, we have the Trivex lens. Trivex is often compared with PC lens. Trivex lens material was initially developed for use in helicopter windshields and fighter jet canopies. Then in 2002, PPG Industries tailored the material's chemistry specifically for use in optical lenses. Just like polycarbonate lenses, Trivex is one of the most lightweight, impact-resistant eyeglass lens materials available and offers 100% UV light protection. So both Trivex and polycarbonate are widely used for safety glasses, sports glasses, and other protective eyewear. Trivex and polycarbonate lenses have a lot in common, but there are some unique benefits that Trivex can offer over polycarbonate. Trivex lenses are cast molded, while polycarbonate lenses are injection molded. The slower cast molding process of Trivex lenses gives a sharper optics and higher f values than polycarbonate lens. So Trivex has fewer chromatic aberrations than polycarbonate, which can be favorable for people with a higher prescription. Furthermore, compared to polycarbonate lenses, Trivex lenses are 10% lighter, have less internal stress, may produce sharper central vision, and have an even higher tensile strength. This makes Trivex lenses even a better fit for rimless frames. So in short, many opticians consider Trivex to be an upgrade to polycarbonate. Now, Trivex does have two disadvantages, however. One, many optical stores charge more for Trivex lenses than polycarbonate lenses. And two, Trivex has a lower refractive index than polycarbonate, so it is slightly thicker. Oh, as a fun fact, when you make Trivex lenses, they smell bad. Some opticians describe the stench as feet soaked in burnt mozzarella. So if you hate the people making your glasses, you can punish them by ordering Trivex lenses. Lastly, we have glass lenses. Lenses made from natural glass will still exist, though pretty small, in optometry today. Because the atomic structure of glass is more regularly arranged than plastic, glass is significantly more stable and scratch resistant. Glass lens also has an ab number of 59, which is the highest out of all lens materials. Most importantly, it has the highest refractive index. Natural glass has a clear advantage here. Its refractive index range extends from 1.5 to 1.9, while the refractive index range of plastic is only 1.9 to 1.74. Hence, the natural glass can be significantly thinner and more aesthetically appealing than plastic, especially for high dioptric values. However, because glass has a substantially higher specific gravity, it is a lot heavier than plastic, which can make the glasses very uncomfortable to wear. Furthermore, glass can shatter easily, so glass lens is not frequently used in optometry nowadays and is often recommended when customers come in with an unusually high prescription. So this video gives you a brief overview of the different lens materials available on the market. Now, technically, no lens materials can be called the best. Different lens materials offer unique advantages and disadvantages over each other. Which lens material you will end up choosing depends on your lens prescription, your career, your hobbies, your self-image, and ultimately, your budget. Discuss your unique situation with opticians and choose the best lens material for you. Of course, watch out for deceptive advertising. Good luck in selecting your glasses. Alright, that's it for today. If you found this video helpful, please leave a like for me and subscribe to this channel so you won't miss any of my future uploads. Eye health question of the day. Which lens material do you think works best for you? Let me know in the comment section. If you don't wear glasses, congratulations on having naturally good vision. But of course, take good care of your eyes because the last thing that you want to do is to ruin your perfect eyesight. Thank you for watching, and I will see you next time.